Okay, so we've made it to section 3.5, the last section in chapter 3. We are looking at linear and nonlinear relations. So let's recall first, what does linear mean? Linear means that when I draw the graph, I will see a straight line. Nonlinear relations must mean, therefore, that when I draw a graph, I will not see a straight line. I will see some sort of curve happening. So today what we're going to do is we are going to compare the difference between linear and nonlinear relations. So first of all, I have a linear relation, y equals 3x, okay? And I have a table of values that I've created. So I've randomly chosen numbers for x. I'm going to plug these numbers into my equation to solve for the corresponding y values. And so I've done that, and I now have my table of values completed. All that I'm going to do is take these points right here. I'm going to ignore this third column for now, and I'm going to plot my points on my line, on my grid. So I plot my points, I connect, and I see, yes, in fact, y equals 3x creates a straight line. Next, I'm going to move on to my second equation, y equals x cubed. So we haven't ever completed any tables of values with x having an exponent. So let's try that out and see what happens. So again, I randomly choose numbers for x, plug them into my equation, and solve for y. So when x is -2, y equals -2 cubed. -2 times -2 times -2, that gives me -8. I repeat this process, and I take just my table of values, just the ordered pairs here, and I plot them on my grid, and what I see is that I do not have a straight line. I have this curve happening here. Well, looking at the equation, that might have given it away to you that it might not be a straight line, because this equation is in fact not in the form y equals mx plus b because of this exponent here. But if I take a closer look at my table of values and I go back and I calculate my delta y, that's the differences in my y coordinates. The way I create this table here, this third column, is I start at the very bottom and I subtract my y's as if I were to calculate just the numerator of my slope, basically, right? Delta y over delta x, but we're only calculating delta y. So 6 minus 3 gives me 3. Keep going. 3 minus 0 gives me 3. 0 minus -3 gives me 3. -3 minus -6 gives me 3. Notice these values are all the same. They're constant. Since these values are constant, that tells me that this, in fact, is going to give me a straight line when I draw the graph. And just as a little side note here, this 3 is actually the slope of our line, y equals 3x. Looking at my second graph, I'm going to repeat that process and calculate my delta y's. So I start at the bottom. 8 minus 1 gives me 7. 1 minus 0 gives me 1. 0 minus -1 gives me 1. -1 minus -8 gives me 7. So I can see that my delta y's are not the same. And the reason being, this is not linear, it's a curve. So if my delta y's are constant, if they are the same as they were in my first example, that tells me that my graph will be linear. If they are not the same, then that tells me that my graph is non-linear. Okay, so delta y, it's the same as our first differences. That's the title for delta y. It's the difference between two consecutive y values when the difference between the x values is constant. What does that mean? Let me go back up for a moment and explain that. When I calculate my delta y, I want to make sure that my x's are in order. Okay, I can't have them randomly assigned. They have to be in order. So -2, -1, 0, 1, 2. -2, -1, 0, 1, 2. And from there I can calculate my delta y's. Okay, so let's look at some observations. For a linear function, I always see a straight line when I draw the graph. My equation can always be written out in the form y equals mx plus b. If I look at my equation, all exponents are 1. X has an exponent of 1 and y has an exponent of 1. And that means, a fancy way of saying that is that the degree is 1. Okay? And finally, if I'm looking at my table of values, my first differences will be constant. If we analyze a nonlinear relation, what happens is when I draw the graph, I will see a curve as opposed to a straight line. At least one of the exponents in our equation will not be 1. So in the above example, x had an exponent of 3. Okay? So that means that our degree is not 1. Okay, in the above example, our degree would have been 3 because 3 is the exponent on x. When I create my table of values and go ahead and calculate that third column, the first differences, I see that they are not constant whenever I have a relation that is not linear. Okay, so let's turn the page here. Let's identify the linear equations. Y equals 3x plus 2. Yes, that is linear. It's in the form y equals mx plus b. Y equals x to the fourth plus 10x. There's an exponent of 4, so no, this is not linear. 3x minus 2y equals 11. So this is a form of standard form. I can see the x has an exponent of 1, the y has an exponent of 1. So yes, indeed, this is linear. And my last example for y squared plus x equals 1. Again, the y has an exponent other than 1, so no, this is not linear. Moving on to example 2, I'm presented with tables of values. These tables of values are already completed. I don't have an equation to look at, and I'm not graphing. So I would like to determine, does this represent a linear relation or not? Well, the way I'm going to determine that is by calculating my first differences. So take a quick scan, make sure my x's are in order. Yes, they are. And I proceed to calculate my delta y. So negative 20 minus negative 16 gives me negative 4. Repeat, repeat, repeat. I see that my delta y's are all the same, which means this must be linear. Moving on to my second example. Again, quick scan to check that my x's are in order. Yes, they are. So now I calculate my delta y's. 25 minus 16 is 9. 16 minus 9 is 7. I continue, and I get 5 and then 3. So my delta y's are not the same, which means this is non-linear. If I were to draw this graph, I would not get a straight line. I would get some sort of curve. Next example, my x's. Are they in order? Yes, they are. Now I'm going up by 2's, but that's okay. As long as it's always a constant number, 2, 4, 6, 8, 10, 12, that's fine, as opposed to 1, 2, 3, 4, 5. Just have to make sure that they are in order and increasing by the same amount. Okay. So my delta y's proceed at the bottom. 35 minus 29 is 6. 29 minus 23 is 6. 23 minus 17 is 6. And 17 minus 11 is 6. Constant, therefore this must be linear. Last example, my x's. So 5, 4, 3, 2, 1. They are in order. They're in reverse order. That's okay. I can calculate my delta y's as long as they are in order, in some sort of order. Okay. I can calculate my delta y's to determine if my function is linear. So 8 minus 6, 6 minus 4, 4 minus 2, 2 minus 0. I have a constant delta y, so yes, in fact, this is a linear relation. Example 3. You are presented with a table of values, and it represents the relation between altitude and air pressure. We want to graph this information on the grid provided. So whenever you're presented with a table, your first column always represents x, your second column always represents y. So the first thing I'm going to do is choose an appropriate interval. I'm plotting the point 1 in 80,000, so I'm clearly not going to go up by 1s on my y-axis, right? So my x's, I'm going to be plotting 1 to 30, so I'm going to choose to go up by 3s. Okay, you could have gone up by 5s if you wanted to. My y values, I'm plotting points from 5,000 to 80,000. So I'm going to go up by 10,000s. Okay. So I've got the points from 10,000 all the way up to 100,000, which will give me enough space to plot these points. Plot my points. Notice that they don't form a straight line. This is a non-linear relation. If I asked you to confirm that, we could calculate our differences, and we would see that we would see that they would not be linear. Okay. So plot my points. I've got this curve that I connect my points with a smooth curved line. Labeled my axes. Air pressure is my y, altitude in kilometers is my x, and I've put a title. Okay. Part B, is this linear or nonlinear? Well, we've already talked about that. It's nonlinear. I can see that because it forms a curve. How does the graph show the rate of change? Well, rate of change, remember, is another word for slope. If I have a linear relation, my slope is constant, but if it's a curve, my slope is not constant. So if I look at my slope, if I imagine my slope between these 2 points, and then these 2 points, and then these 2 points, and then these 2 points, the slope is getting shallower. So I'm going to say that my rate of change, my slope is non-constant because it's not linear, and it's decreasing because it's getting shallower as I move up in my x values. Part D, use interpolation to estimate the air pressure at an altitude of 20 kilometers. So go back to my graph. X is 20, so I'm going to approximate, read off my graph. Y will be approximately, well, it's higher than 10,000, less than 20,000. Looks like it's about 15,000 according to my graph. Okay, remember that's just an approximation, doesn't have to be exact. So that's it. We have reached the end of chapter 3. Here's your homework, page 146, number 7, page 179, numbers 1 to 4, and 6 to 8. I will be posting additional review questions if you're interested in completing them, and I will also be posting your assignment shortly, which you will have a couple of days to work on. Any questions, please reach out to me. Again, I'm here to answer any questions you may have. Thank you. Bye-bye.